Hello, welcome to this session, this live session of an introduction to programming through C++. So let's see. So let me start by looking at the questions that I had received earlier. So there is one question by Rahul who asks, what is the use of pointers in C++? Okay. So one of the major uses of pointers is to refer to memory that is allocated on the heap. So you have seen that, right? If you are allocating memory on the heap, then pointers form the only way of accessing that memory. And another reason to use pointers is that suppose you want to pass an argument, then sometimes it is easy to, so you can pass a pointer to it rather than copy the whole thing. And of course, there is a notion of references, but references are also related to pointers. So that is really, those are really the main uses. Okay. So referring to variables which have been allocated on the heap, and maybe succinctly sending information about a variable. So instead of sending a copy of the variable, you can send a pointer to the variable. Okay, good evening to all those people who have been joining. And let me go to the next question. So, okay. The next question is about, says something like this. Sir, could you please inform the type and format of the question paper which we can expect in the certification exam? The paper is going to be pretty similar to the quizzes that we have been having. Okay, in fact, some of the questions from the quizzes might appear, maybe with some minor variation, or perhaps even without any variation. So what is the type then? The type is going to be multiple choice. So which means you will have to choose either one correct option, or occasionally you may have to choose more than one correct option, as might be indicated. And then there will be there could be fill in the blanks. Now, as a rule for fill in the blanks, you should choose the simplest possible answer. And you will be instructed, and you have been instructed throughout this course, that you should not include unnecessary spaces, unnecessary quotation marks. Okay, so I think you have had practice about this, so even that is not a problem. And of course, there might be natural ways of referring to something and non-natural ways of referring to something. So you are expected to use the natural ways of referring to whatever you are referring to. Then finally, if you are expected, if a number is expected, then you should really, you should not give an expression. Okay, you should really you should really write that number out in full. You should do the calculation and write the number. So simplest possible answers in case of in case of fill in the blanks, and in addition, you should expect multiple choice questions. Okay, while overloading the insertion of extraction operator, why return type operator overload function is reference to iStream or OStream? Okay. So yes, so this is a bit of a tricky question. So if I write something like Cin greater than x, then this is an expression. This expression happens to move something from C into x, but it is an expression also. And the reason this is an expression is because by making it into an expression, you can write something like Cin greater than x greater than y. So if you write, so Cin greater than x itself is an expression which evaluates to an IO stream. Okay, so if you, so that is what allows you to do consecutive IOs in one statement. If you don't want, if you are willing to live without this feature, so every CIN will just contain just a single extraction. Okay, any statement will contain a single extraction. Then what you are saying is not necessary. Then the return type, return type doesn't have to be a stream or a reference to a stream. Okay. So because you want this chaining, you want multiple extractions to happen. That is why you want that return type to be a stream. All right. And why is it a reference? Because you don't have a copy of the stream anyway. You already have a reference to it, and so therefore it has to be a reference. Okay, I think I have these things which are going up over here, so maybe I'll just look at these first. Okay. Sir, in the beginning, Deeptanshu Srivastava asks, sir, in the beginning of the course, you mentioned that we can create airport simulations, so I will guide. Sir, how to design algorithm for it? Okay, the airport simulation is discussed at great length in the book. Okay, so you can read from it. But I can tell you roughly how that simulation has been designed, or in general how such simulations can be designed. So for that, you need to get a good understanding of what do you think is going to happen on the ground or in the system that you are trying to simulate. Okay, so the first question to ask is what is the state of the system? Okay, by state I mean if I want to describe what is going on in the system, I have to say something like, okay, there are some aircraft over here. The aircraft are located at this point, and maybe there might be some state which is not immediately visible. So some aircraft might already have been given permission to take off. So that is an important part of the state. So you have to say, what is it that I need to know? Yeah, so a good way of defining state is, what is it that I need to know in order to predict what is going to happen next? So in the case of physical phenomena, the state might be something like the positions, velocities, temperatures, and the logic for predicting what happens or simulating the system will come to you from laws of physics. So based on the current state, you will be able to predict the next state. In case of something like an airport, the logic of predicting the next state will depend upon whatever strategies you may have designed in building that system. So you may say that first I'm going to give priority to arriving aircraft. Okay, so then that way your system will actually assign permissions. Okay, so again, of course, yeah. So those are going to be the differences. That is how the logic of the system is going to be built. So you have to worry about two main things. One is the state of the system. Okay, so what is it that I need to know about this, about the values or the objects in the system in order to predict what is going to happen next. Okay, so that's one part. And if it is a man-made system, then what are the rules by which the system can progress? Okay, so am I going to give priority to something? Okay, or there are some rules which are plainly again like physics rules. So if an aircraft is moving, it is going to move. It has been assigned, if it has a certain velocity, you can't say stop it immediately. Okay, so you can request it to stop, but then it will stop only after a little while. Okay, so in any case, you need to know what are your policies. Okay, so somebody is going to make some decisions. So what are the decisions that you are going to make, and what is the state of the system? So once you design that, then the basic simulation loop is fairly simple. you have the current system, you have the current state of the system, and then you know how the system can change, either because of the laws of physics or because of the goal. The goal might be to move as many aircraft as possible. So in which case you will request aircraft to move. Or the goal might be to allow incoming aircraft to land early. So that way, that's how you will give permissions. So the rules of the system, either physical rules or man-made rules, have to be known, and that way you can do the simulation. So the basic loop will be the initial state, the modification, and that's it. You just keep on doing it over and over until and in each iteration you are advancing time. So you keep on doing these iterations until as much time as you want the system to run. Okay. The next question is by Khushi Gupta. Sir, when will we get our admit card? Khushi, I'm sorry, I can't tell you this. You will have to take this up with the NPTEL IITM, the NPTEL administration. Okay. Okay. Good evening, Habib. Sir, the general Kate term of cos x. Okay, the Kate term of cos x is going to be the series for cos x is going to be derived from is going to be the Taylor series for it. So just take the Kate term. So take the derivatives and the Kth derivative divided by k factorial. Okay, times x to the times delta to the power k. Okay, so then Habib asks, sir, the paper will be MCQ types or answered, no coding. Okay, so there will be no coding, but I might give a program in which I might ask you to fill in the blanks, but I won't ask. Usually the fill in the blanks will be something very short, okay, a very short, exactly like what you have seen in the quizzes. Okay, no, there won't be writing of any programs. Yeah, so Sanjay Kumar Konakandia asks, is course completed with 11 weeks of content or another week is left? Yes, another week is left. It will be coming up soon. In this week, we are going to make use of whatever you have learned so far, and we are going to design two somewhat large programs. So in the last week, we started this whole business about medium-sized programs. And in this week, we will design two more medium-sized programs. I don't mean large, I mean medium-sized programs. So since you have asked this question, let me tell you what those programs are going to be. So those programs are going to be about, the first program is going to be a circuit editor. Okay, so it's going to be a very, very simple toy circuit editor, but it will allow you to click on the screen and create a circuit on the screen. And then there will be a button on the screen which you will create. Okay, so you will create using simple CPP, you will create a button, and then if you click on the button, then that circuit, the values in the circuit will be calculated. Okay, so this can be done in about, I think, less than 200, between closer to 150 lines of code, and we will discuss this. And in fact, the source code is discussed, and in fact there is going to be a question in which you will have to look at the source code to answer that question. So that's one of the questions in the quizzes. And then the second program will be about simulating movement of planets around the sun. Okay, so you know Newton's laws, right? You know Newton's laws of motion, and you know Newton's law of gravitation. So using that, we will simulate the movement of particles. So again, somebody asked a question about airport simulation. So this is not airport simulation, but all simulations have a basic structure which is somewhat similar. So in this simulation, you are going to again have the state of the system at this current time step. Then you have to figure out what happens in this current time step and what rules are we going to use, and depending upon that, calculate the state of the system at the next time step, and then just keep on doing this. So that's how you will do the simulation. But you will actually see the planets moving around, moving around the sun. And so when they tell you that planets describe elliptical orbits, you will be able to do the calculation yourselves, and you will be able to see that yes, the two laws, the law of gravitation and the laws of motion, actually imply that the planets will describe elliptical orbits. Okay, or maybe uh, if you get the velocities and the positions in a certain different manner, they will describe parabolic or hyperbolic orbits as well. But in the simulations that you will see, uh, they will describe elliptical orbits. Okay, Gautam Kumar asks, what is ceiling and floor, sir? Oh, so ceiling of x is simply the largest integer, uh, integer smaller than or equal to x. And I'm sorry, ceiling is the smallest integer larger than or equal to x, and floor is the largest integer smaller than or equal to x. Okay. So as an example, the ceiling of 5.6 is 6, the floor of 5.6 is 5, and if you take an integer, then its floor and ceiling are the same. So floor of 5 is the same is 5, and floor of ceiling is also 5. Okay, so ceiling and floor are one way to change a to approximate a real number by an integer. It's not the only way. You can also do rounding, and typically what rounding means is that you go to the integer which is nearby. So the rounded value of 5.6 will be 6, and of 5.4 will be 5. Okay, so so that's yeah. So that's what ceiling and floor are. Okay, sir, could you please explain assignment 7, question number 5? Ah, okay. Okay. So let me see. I will try. I will have to dig that up. Let me do that. So you know, Aditya, this is not a way. This is not the right way of asking these questions. Okay. So in fact, I'm going to ask you to write that question, to explain to me what you did not understand. Okay. So because if I don't know what you don't understand, then how do I explain? Because as far as I'm concerned, I have already explained. So kindly rewrite that question saying what you don't understand. Okay. Okay, Chinmay is asking, sir, which course would you prefer us to take after completing this course for a second year CSE student? Okay, so there are several. I mean, you know, right? You have a good idea of this. You know what are the next courses. So I think there are courses on discrete math. Okay, and then there are courses on data structures. So if you're interested in programming, I think the data structures would be a good the course on data structures would be a good course. And yeah, so those are sort of the two natural courses. But there could be other courses also. I think if you are in an engineering discipline, or if you are inclined to studying say engineering mathematics problems, then there could be courses about that. There could be a course in numerical analysis also, for example. And you could also yeah, I think that's about it. I think that's what I can say. Okay. All right. Let me go to this side. Okay, so this I did. Okay, so how do we solve complex problem statements using C++? Okay. So how do you solve a complex problem? Okay. The first step in solving a complex problem. I assume here you mean solve a complex problem using a computer. So so the first step is in figure out how will you solve the problem if you have to solve it using pencil and paper. Okay, in this course, we are not really in the business of designing completely new algorithms for tricky problems. Okay, what we are interested in this course is to really write a program if it is already clear to you how you would solve the problem manually. So for example, if we are doing an airport simulation, since we had that discussion, it should already be clear to you that if you know the current state of the airport, if you know the thinking of the air traffic controllers, okay, then how would the system evolve? Okay, so this information, how is the computation going to proceed? Okay, in a pencil and paper sense, should be with you. If that is not with you, then you need to take another course perhaps. Okay. So if that information is with you, then you figure out what is the state. So if you identify that this is the state, and again when I say state, what do I really mean? What I mean is what data do you need, which properties of which objects do you need in order to calculate the next steps. Okay, so that will tell you what variables you are going to need. So you need to have a program in which those are your variables. And then the updates are going to be the code that you are going to write. Okay, and this is typically going to be in a loop. Okay, so that's what it is going to be if it's a simulation. If it is some other kind of a calculation, again so if you know how you are going to do the calculation. If you know how you are going to do the calculation manually, then it's a matter of mimicking what manual computation you are going to do. Okay. Let me say something a little bit about about coding of complex systems. Okay, so I think we have been doing this. We have to, as far as writing the code is concerned, okay, we have to write the code so that it matches the actions that we do, the actions that happen in our system. What I mean by that is that in our system, in the system that we are working with, it could just be a calculation, it could be a simulation of a process, whatever it is. There we think of some operations. Okay, so the operation could be to move a planet. Okay, or the operation could be to calculate the nth term of a series. Okay, so these are sort of operations which you will think of when you are solving the problem, when you understand the problem, when you are trying to understand the problem. So you will say that, look, in order to do all these things, these are the operations, and maybe you will think of sort of complex operations also. So those will naturally be your functions. So if you are thinking of a complex operation, so say maybe you want to move a planet. So in order to move the planet, you will first have to calculate the force on it, and then you will have to decide how much so what acceleration that force will cause. You will have to look at what is its current velocity, and based on that you will have to do the movement. So the simple thought that you had, that now I must now move the planet, might actually require several calculations. So those calculations will often be nicely put inside a function. Okay. Similarly, when you think about the objects, if you say that there is a planet object, if you say that there is an aircraft object, Or if you say that there is a matrix object in your system, in the calculations that you're doing, then you should have variables which correspond to these objects as well. So either they could be structs or they could be classes, which are simply structs with access control and member functions and things like that. Okay, so that's how you build up the data part. That's how you build up the function part of it. Okay. So if my answer is not completely clear to you, or if you have a follow-up question, please think about the answer and ask another question, and I'll be happy to discuss it. This is actually quite a nice question. So Ashwin Fegde, I think, yeah, please do that. Okay. Okay. So I joined this course to credit transfer. Okay, so Bharati has already answered it. So I think, yeah, I think. Okay. I think अभी कोई there are no questions now. There are some? Okay. Okay, so there is a question about the photo. I think Bharati ma'am will take it up. And how do we start with data structures? So I think there is a course on NPTEL with data structures, and we have already talked a little bit, right? So what have we talked about data structures? We have talked about 2-3 important data structures that you need. Okay, so one is the vector data structure, so which is kind of a extensible array. Then there is the map data structure. Then there is the set data structure. So in the data structure course, you will get so how exactly that data structure is implemented, how each of those member functions are going to be implemented will be explained to you, and you will be asked to design similar data structures as and when needed. Okay, and then in addition, you will also do things like solve problems in which you have to use those data structures. So we have done a little bit of that, but in the data structures course itself, the problems will become somewhat harder because after all, it's a more advanced course. but they will become harder, and you will be required to use the existing data structures or maybe compose data structures just as we were doing here as well. But as I said, the problems will become harder and the data structures could become more complex. Okay, how to think about the logic implemented in the program if the objective of the program is too tough. Okay, how do you work on anything that is tough? You break it down into pieces, right? You say that if I want to climb this mountain, I have to do it one step at a time. Okay, so I have to first get to this base camp, then okay, so in order to climb, I need to learn all these things. Then I have to actually do the climbing, I have to prepare for climbing. Okay, so you try to break up that complex thing into pieces. It is possible, Aditya, Anshu, I'm not understanding your question, but based on what you have written over here, that is what I can say. Again, you can go back and ask the question again if you want more clarification. Okay. Sir, say something about exam. Hey, don't get so worried about it. Okay, as I said, it's going to be exactly like the quizzes that you have seen. So I think there will be about some 50 to 60 questions, and it's a 3-hour exam, so each question will require you to think for maybe 3-4 minutes, 2-3 minutes, and it will either be a fill in the blanks or it will be a multiple choice question. Okay, what courses should we aim to join after we finish this one? Okay, so I think data structures, discrete math, numerical analysis, and after data structures, design and analysis of algorithms. Okay, and of course you can do things like databases, computer networks. The entire CS curriculum is there for you. Okay, good evening, good evening. I'm not properly audible. So I hope the people who are monitoring this are keeping track of this. Apparently I'm not audible. Hello? So, okay, there is some disturbing sound behind the live session. Okay, let me just check. Let me at least tell these people what you are asking. Just 1 second. Okay, maybe I will ask them. Hold on just a second. वो कह रहे हैं कि कुछ नॉइज है आपको सुनाई दे रहा है नॉइज ओके 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 थैंक यू अच्छा आपको ऑडियो में सुनाई दे रहा है ठीक है अच्छा ठीक है ओके Okay, so Kamlesh Kumar, has this helped? I think perhaps I think my microphone had moved a little bit, and perhaps now this should be better. Okay, so please drop a text over here if it is better or if it is worse, and if it has not improved, perhaps the people over here will try to change further. Okay. All right, okay. So, sir, how can we develop an idea to solve problems using recursion method? Okay, so we have not really done this in the course, okay. And the reason for that, okay. Oh, there is only some bee-like sound. थोड़ा आवाज और भी है, देखिए, ये कुछ
ऐसा आ रहा है ना? हाँ? इसका फैन है. अच्छा अच्छा. Hey, apparently it is the fan on this computer. I'm really sorry that it is there. Unfortunately, I can't help it. Okay, so hopefully you are able to hear reasonably clearly, although with perhaps slight difficulty. Sorry about that. Okay, so I was talking about recursion. So it's a tricky. Using recursion is not an easy thing. Okay, so sometimes the problem is given to you and naturally recursion comes up. Let me give you a simple example of where recursion comes up naturally, which you probably already know. Okay. So, you all of you are probably learning some calculus or something like that, and in that you are given algorithms to or you are told how to differentiate a function. So how do you differentiate a function? Well, if it's a sum, then you take the derivative of one side, you take the derivative of the other side, and you add it up. What is this? This is a recursive algorithm. So now that I have told you this, if you can get your hands on the two sides, then you should be able to write a recursive algorithm for solving this. Okay? Then in one of the problems that we did, we used recursion to print all the subsets of a set. Okay, so what was the logic over there? So it was not obvious that you could solve this using recursion. But what you could ask is, in order to print all the subsets of a set, can I think of the problem as print all the subsets of a set? Okay, print subsets of this kind. Okay, I guess that's the better way of saying it. First print the subsets of this kind and then print the subsets of this kind. And how do I print the subsets of this kind? Then again, I further break them down. So what we did over there was, if we had if our set had elements x1, x2, x3, we first printed all the subsets in which x1 was present. Then we printed all the subsets in which x1 was not there. Okay, so you will have to look at the problem to be solved, and you can say, okay, can I break this down? And when I break it down, can I use recursion to solve that? Okay, it's not easy. I don't want to, I mean, if I try to explain this in sort of 5 minutes, I will be deceiving you, because it requires a much bigger explanation. And yes, and that will be one of the things that you will learn in the data structures course, or certainly in the algorithm design course. Okay, but it is going to be something like that. You are going to ask, is the problem that I am trying to solve, if I try to break it down, will the subproblems be, do the subproblems that I'm trying to solve look like my original problem itself? And if so, I can use recursion. Okay. Okay. Uh, Sir, tell more about heap memory and how system does memory management. Okay, so when you run your program, okay, so there are two kinds of memory, that your program is allowed to have. Okay, one is the activation frames that we have been talking about. So there is a region of memory which has been set aside, or which has been marked by the C++ compiler or the runtime system. And so the memory that is available on your computer, some of it has been earmarked for use in activation frames. So whenever you call a function, a new activation frame needs to be created. So that activation frame comes from this activation frame region of the memory. And when the function finishes, that activation frame
is released. So it goes, so that region now again becomes free, and it can be allocated if you call another function. Okay, but that is not all. Sometimes you would like to create some object when you are inside a function, and I'll have that object be available to the calling program, to the calling function. So in which case you need a separate memory which is outside the activation frames, and that memory is called the heap memory. So again, it's a region that has been marked as such, and whenever you want something allocated in the heap memory, you do it with new, and this doesn't happen automatically. You have to ask for it in your program, and when you feel that you don't need that object anymore, you delete it. So delete is like freeing that memory. Now, the heap memory management is a little bit tricky, because you will get some memory, you will get some more memory, you will free some memory, and when you free that memory, the region that is freed you have to keep track of that region, and that keeping track of that region is a little bit complicated. Okay, but that's what memory management is, and you may learn a little bit about this also in the data structures program, but you may learn more about this in some other courses. Okay. Gautam Kumar is asking, sir, the number of easy, moderate, and tough questions in the exam. Gautam, it's going to be similar to the quizzes. I don't think it's going to be harder or easier. Okay. So I think the rule you should use is that look, I mean, you have given lots of competitive exams now, so you probably know how to give competitive exams better than I do. But there will be some 50-60 questions, so the rule is going to be something like 3 minutes per question, and of course you have to quickly decide whether you can answer it or not and move on. Okay, sorry, yeah. So I don't think I can say more, and yeah, I don't think there will be particularly tough questions. Okay, so maybe occasion, and of course what you think of as tough question and what I think of as tough question might be different. So one person might find one question tough, another might find that to be easy, but some other thing might be tough. But yeah, so it's going to be of the same standard as the quizzes that you have been solving. Okay, Deeptanshu, sir, please tell us about priority queue also. Oh God. So that is a proper topic of the data structures course. Okay, and of course maps and vectors are also proper topics of the data structures course, but we introduced it because I think we can use them. In the data structures course, you will be able to implement those things also. Okay, so since you are asking what a priority queue is, I will tell you, but don't get too worried about these things. Okay, yeah. So if you don't understand it, don't worry so much. Let me try to explain it. I really should write it down, but I don't think I have anything quite easy here to write it down. Okay, so what is a priority queue? Okay, so a priority queue is a set-like object. Okay, except that. So like a set, you can insert things into it. Okay, just as in an ordinary set, you can insert things into it. But unlike an ordinary set, the operation of removing something from the set is rather interesting. Okay, so let us think of a set of integers first. So you can keep on inserting numbers into the set. Okay, and at some point you can say, okay, now give me the smallest number. Then maybe you can answer some addition, you can enter some additional numbers, you can insert some additional numbers, and maybe again you can say, give me the smallest number. So say I insert 5, 10, 3 and 6. So after that I ask for the smallest number, then I should get a 3. After that, if I ask for the smallest number, I should get a 5. Okay, so when I ask for the smallest number, that smallest number is removed. And so if I ask for the smallest number again, the second smallest number will be returned. But between two requests for give me the smallest number, you can insert additional numbers. So whatever the current set is, the smallest in that is always going to be returned. Okay, so that is the set of operations which are allowed on the priority queue. Okay, now you may think, okay, I can do this with a vector as well, and you are right. I could look through all the elements of the vector, and I can say, okay, just let me go through all of them and find the smallest, and then I will remove that and I will return it. Okay, but that will take time, that will require you to look at that entire vector, and that's why it will take a lot of time. It could take a lot of time depending upon how large, how many elements you have already inserted into your set. Now, a priority queue has some very interesting logic. It has some very interesting way of organizing that set, so that if you ask for the smallest element, you will be able to get it very fast. Not only just one element, even if you ask for lots of elements, you will get them very fast. So you could say that, look, are we going to keep the numbers in the set in a sorted order? Okay, now that could be one way of doing it, but that is not going to work because you are also going to insert something into the set. So if you are inserting something into the set, then what happens? Then if you are keeping things in the sorted order, then you have to, if you insert something in the middle, you have to shift all the elements upwards. Okay, so it is a tricky problem, and you can look at the solution, or you can wait until you take the data structures course, but it's a very clever solution. And since you are asking me this question, I think you will feel very pleased when you see that solution. It's a very interesting solution. So now that you have asked me the question, do go and look it up. You can understand it. Okay, so that's what a priority queue is. And here is a very simple example. Here is a very simple use of a priority queue. I get numbers, I keep on inserting them into a priority queue, and then I say, okay, give me the smallest, next smallest, and so on. So each extraction is going to happen relatively fast. In fact, if there are n elements which are in the queue right now, then each extraction of the smallest will happen in about log n steps. And as a result, this can be a very nice sorting algorithm also. All right? Okay, so I think that should be an adequate thing. Yeah. Okay, all right. So Raikota Pavan Sai says, sir, please give any suggestion. I'm not prepared well for the NPTEL exam because of my semester exams in the college. Okay. Look, I mean, I don't know how much time you are spending in the semester exams. I don't know what your priorities are. I think your priority should be your college exams, because the college exams you certainly want to do well in the college exams and you want to get into the next year. Okay. What else can I say? Okay. So I don't know. Does it really matter to you that you get the certificate? Okay. If it doesn't matter to you that you are going to get the certificate, then you have a link to this entire system, right? So you can do the quizzes and the programs a little bit later also. So I would say give more priority to your college, because they are not going to wait, and the marks that you get in the college are going to be directly important for your career. All right. So yeah, I don't know what else to say. I want to learn web development from you. So as Virendra, okay, I have to disappoint you. I don't know that much about web development. Okay, I know about programming, I know about data structures, I know about algorithms, but I don't know that much about web development. So I'm afraid I will not be able to teach you that. Okay. Mokshu Mishri, good evening, sir. You teach very well. Oh, thank you. You have lectures in so many clear words which can easily be understood. Oh, I'm very happy about that. Okay, I'm glad that you like the lectures. Okay, nice to have you. Is there any, Renuka Kumari is asking, is there any negative marking? No, there is going to be no negative marking. So you can guess. Okay, go ahead and guess. Okay. Vignesh Sharma says, I totally loved your approach in this course. Oh, I'm delighted. Thank you. Thank you for saying that. Okay. How many code program questions are upcoming in the exam? Okay. LNCTI citizens. Okay. So look, I mentioned this earlier. There are no, you don't have to write a program in the exam. Okay, it's going to be exactly like the quizzes, which means there will be multiple choice. There could be fill in the blanks. The fill in the blanks could refer to a piece of program, and you will have to say what this blank one should be filled with, but no, not full programs. All right. Okay, so yeah, so we have some 10 more minutes. I think if there are more questions, I'll be happy to answer, and I will stay on for the 10 more minutes. All right. Lokeshwari is asking, I have planned to do a project based on simple CPP library. I am not getting how to input. Oh, it is described in chapter 21 of the book. Okay. So this was not covered in this course, but it is described in chapter 21. All right. Week 12 will be live as per the usual thing. I think in a couple of days. Usually it becomes live the Friday or Saturday before the week begins, right? So yeah. Okay, thank you, Raigota Pavan. So look, I may not be able to pronounce the names of different people. I'm really sorry about that, but I have to go by, I have to make the best effort I can. I'm sorry if I'm mispronouncing your name, or if I'm sorry if I'm referring to you by your last name or your middle name, which is not how you usually like to be referred to. Really sorry about that. So Lokeshwari, if you have difficulties with that, oh, actually I can tell you another thing. In the IDE, in the code blocks IDE, you do have the programs from the book, a section called the programs from the book. So so you can just look at those programs, and that will also tell you the additional operations that can be done. Okay. Unfortunately, I was not able to get to that part in this course itself, but it is there. It is in the IDE also. You can see programs which use that. If you have difficulties, you can send me an email, and I will be happy to help out. Okay, so Lokeshwari is asking again, can I create software in code blocks? Can we create our own header files? Okay, so all right, so let me talk about code blocks. Okay, Now, code blocks is something called an interactive debugging development environment, and like many such environments, it's a very complex piece of software. Okay, so what that means is, so it's so the if you sort of run the basic code blocks, it will look like the set of dials and instruments that you see when you enter the cabin of a pilot. Okay, so if you enter the cabin of the cockpit of a modern jet, you will see lots of screens, lots of dials, lots of switches, lots of digital readouts, and that is very confusing to the user, to a novice pilot. And in our case, the standard code blocks or the standard Eclipse IDE is also very complicated looking. So, for example, one big change that we have done in the code blocks that we have supplied to you is that we have made it so that it allows you to run a program which is in a single file. So header files and things like that are required if your program is in several files. So since we didn't expect people to write large programs in this course, okay, we said that let's keep things simple. Let's not tell them what a project is, and because that if I have to explain that in the beginning, most of you would start getting bored. Okay, you probably want me to tell you about problem solving and programming, not about how to what keys to use and what does this thing of code blocks means. So to simplify that, the code blocks that has been supplied to you is a very simple object. Okay, but if you want to do big development, and by now you should be able to do it, by now you should be able to read the manuals of different IDEs, and so you should be able to do that. If you run on Unix, then we have the library, simple CPP library, and there is a configuration file, so that you should be able to use. Okay. On Windows, things are slightly tricky, I think, but on Unix, the development is going to be easier. On Windows, I'm afraid that, you will have to do some work. So developing really large programs on Windows is not, we are not strongly supporting it right now. Okay. Yeah, so again, Lokeshwari, if you want to make a project which is say 200-300 lines of code, and you can do a lot in 200-300 lines of code. Next week, you will see from next week that the projects that we have in next week are done in less than 200 lines of code. Okay, so you can do a lot, but and so please go ahead and try that with the library. And somebody else was asking about header files. So you can develop your own header files on Unix, but on Windows running on code blocks, I'm sorry, we have not supported it, because that would be something you should use the regular code blocks to do that. Okay. All right. Whenever week 12 will be live, Bharati has said that it will become live by Saturday. Would exam be tough? Hey, don't worry so much about it. It's going to be as tough or as easy as the quizzes have been. So don't worry about it. Look, you should be having fun in this course. This is not sort of your standard college course, right? You are here because you want to discover something new, and you should be here if you want to have fun. And I hope that you are having fun in this course. I hope you are solving the problems and saying, oh wow, now I know how to do this. Okay, or I didn't know how to do this on a computer and now I know how to do this. So I hope you are doing it for having fun. Okay, can we create our own header? Okay, good. I want to study Python programming language. So can you how much is the difference with C++? Okay. All right. So It is different and it is not different. So the basic ideas are similar. Okay, so what are the similar ideas? So there is a notion of loops, so that is there. Okay, there is a notion of recursion which is there. There is a notion of structures which is there. There is a notion of arrays which is there. The array in Python is like a vector, so it's an extensible array. So I guess the array. So yeah, so like a vector, there is an extensible array called a list in Python. There are also maps. So just like the maps of maps in C++, there are maps. Okay. Now in Python, Python has the typing in Python. The types are a little bit more flexible in Python. So for example, in Python, you can have a list which contains any kind of element. Okay, so sometimes that comes in very handy. All right. And what are the other important ideas? So the syntax of Python is sometimes very nice. Okay. So for example, you can write parallel expressions such as a comma b equal to b comma a. So this would exchange the values of a and b. Okay. And sometimes if you want to return multiple values from a function, you can say return a comma b. And you can write a comma b equal to f of c comma d. Okay. So these are sort of very convenient syntax features. What else is there? So there are expression. There is something called list comprehension. So you must have seen things. So people in mathematics or in set theory, you write something like C is the set of elements X such that X is even. Okay, or so the syntax is that C equal to open brace X, open brace, then X, then that bar saying X such that, and then you describe the properties that X is supposed to have. Maybe X can be derived from another set. So there are such very interesting syntax that is available, which can make your program much easier to understand. Okay, but so the fundamental aspects are quite similar. Okay, so if you understand recursion, if you understand iteration, if you understand function calls, if you understand lists or vectors, whatever you want to call them, if you understand maps, you have say 80% of the Python. You know 80% of the Python that is to be known. Okay, but the way, the whole thing about things being loose as far as flexible, as far as types are concerned, makes it different. And of course, Python is what is called an interpreted language. So you don't have to compile things. So it's convenient in some ways. And finally, there is one more advantage to Python. So there are lots of libraries which are available now, and the linking of these libraries is easier, I think, and because of that you can use code which has been built by others. Of course, you get C++ libraries also, but somehow the linking of the libraries is easier in Python. Okay. Revision of lectures and assignment revision is enough to get good marks in exam. Yes, definitely. Revision of lectures and assignment revision is definitely going to be enough. Yes. Okay. I think we are probably at the end of our time. Yeah, it's 5 minutes past 6, and I think there are no questions. So I think we can probably stop. All right. So thank you for coming, and wish you all the best for the examinations. And I hope you had fun in this course, and I hope you will also like the week 12 lectures and problem sets which are going to be coming up pretty soon. All right. So bye bye, and we'll stop over here.